Yay.
Go ahead, Claudio, kick it off.
Oh boy, we're going to talk about fuel now.
Fuel. This is the fun stuff.
Yeah, the fun stuff. Yeah, here's where you get the engine to hear the engine brappy brap or roary roar,
The big bada boom.
or go into burble mode. I hate burble mode.
Come on, every
Anyway,
BMW needs it. It's a slider on the JP3. So
hello. Can you set my Lexus 2018 with some burble mode?
yes, grab
No.
this slider on your JB4 and all the way up.
Well,
So we're going to
all
cover
right.
in this fuel and fuel system configuration. Uh, we have fuel system requirements. That's going to be as far as lines, pump, dampening, rails, the actual configuration of the mechanical side of things. Then we have,
Compatibility of components.
there you go. Um, by the way, not all fuel pressure regulators are rated for E85.
And not all fuel pressure regulators are rated for the same pressures.
That's right.
Yeah, very, very important. All there's a
Very,
lot of
very
stuff to cover.
important.
Yeah.
Um, and we also have, oh, geez, I just clicked off it again. Go ahead, Claudia, take this over for a second.
All right. So I'll start with the pure basics. Where so you've decided on your application, what it's going to do: street car, race car, drift car, drag car, ballistic missile, whatever you want to call
Mm.
it. So your fuel requirements or your fuel system requirements are things that you need to consider before you even get started or hooking everything up. Because if you have small injectors for a E85 or methanol car, then you are not going anywhere. That'll be a limitation, and you don't want to be ripping out, fuel rails and injectors and manifolds and replacing stuff or buying hardware more than once. You want to do it right from the get go, which should be the caveat for everything. Do it right the first time. Measure twice, cut once.
One of my business mottos is do it right, do it once.
Yes, exactly.
Right for
Um, I,
design, do it right, do it once.
I'll
Anyway,
be perfectly honest. I probably am. We're all probably guilty of spending thousands and thousands of dollars on stuff that we didn't really need.
had to redo.
Have to redo just because you thought, oh, if I do it the cheap way, maybe it'll work. No, it
I
never
can make
does.
it work with those knockoff injectors. Don't worry,
It,
guys.
it,
And
it
injectors are
never does.
completely useless.
And never does. And we're going to talk about that a little bit too. So, going with the basics, fuel system, you have your number of outputs connected to the number of cylinders. As we can discuss later on, multiple stages of fuel, but let's keep it simple with just one stage. Your firing order, we've already talked about that in the ignition section. It'll apply to the same thing. The cylinder order is what is done in the ECU, or your hardware firing order if the ECU does not have the option to do custom firing order. The ECU will require quite a few values that we can look at to know exactly what size the engine is, how many injectors, how is the ECU firing the injectors individually or in groups, depending on some factors like, let's say, trigger setup. If you only have a crank sensor, you may want to just do batches of injectors. But assuming it's all sequential and we have individual control, then you have certain settings and options available to you to do vastly different uh, control strategies. Whether you're only using a throttle position sensor, whether you're going map sensor, whether you're crazy and you want to go map sensor and EMAP and engine pressure ratio and all that jazz, something to take into consideration every time you start a project.
So I'm going to say that this whole theme of this video series has been you start with a good source. And that's very much the same for being an audiophile, very much the same for doing anything ignition, wiring, fueling related. Okay. So as we're going through this fuel system, let's talk about this in order of how that fuel gets to your engine. That is the source of that fuel. First off, if you're going to the cheap gas station and it's corroded, and you're filling up when a tanker is dropping off and it's mixing up all the stuff inside of that huge tanker, probably not the best time to go fill up. Uh, that's your source, right? Once we get past that, what is in the tank? I can go grab one from the garage real quick. But they make, if you have a Walbro 450 for your fuel pump, they make a stainless element on the base of that pre-pump filter from in-tank pump setup. That is designed to flow at a 200 micron filtration rating and have no restriction for the pump whatsoever, and also cannot be crushed. And it also has a pre-built membrane to allow to be fully set down to the base of the tank, which is one of the problems with the socks, which can be floating at a certain angle or cannot be floating depending on what is in the element, how much heat has gone to the pump that then burns the outside of the sock or burns what it's picking up and eventually clogs the pump and makes it run hotter. Source, very important, right? From there, we're going to have our line of choice. We can go with a factory set of lines, which is usually a stainless steel element. Something that is let's say we have a flex fuel card, so we'll have an E85 rated rubber, or even better, PTFE for those lines going to it. Many people will say, well, why would I go from this line to this line to this line? Well, it's the amount of, let's say, the gaseous expansion of this fuel. So if we have, obviously we can't smell everything, but vapors can come out of rubber much easier than they can come out of PTFE. So it is safer to have a better sealed fuel system. Now, the vapor from that line might never catch fire, might never have problems, but it is better to use a stronger base material to keep our fuel system working for as long as we can. PTFE is a self-cleaning style, like Teflon sort of thing anyway, so it's what you'd want to have for an alcohol-based fuel because it won't degrade with time. That's the other real factor there.
And then the next one is the next filter.
Yeah, but even before that, the fittings. If you're running a high pressure system, push lock fittings are going to fail you. You're going to be creating a fire hose effect on your engine somewhere of a fuel fitting shooting off into the engine bay, and your 120 psi pump is now going into your nice, beautiful powder coated engine bay. So,
or your nicely hot exhaust.
Yeah, that's good. That's what you want to see. So
yes.
Push lock fittings are great under, let's say, dynamic pressure, which would be our pressure differential. If we have our base of 43.5 psi, we make 20 pounds of boost, and we've got line losses, our dynamic might be somewhere around 75 psi. That's as far as I would run push lock fittings. Now, if you've got a base pressure on a mechanical setup of 120 psi, those push locks aren't going to last.
No, I'd even go as far as saying push locks are good for NA, I think.
Yep, that's a good way to put it. And even some NA setups will go past, because you're gaining an engine response with higher fuel pressure, as well as the cavitation of that fluid will be less likely to cavitate when you have higher pressures. You will have a certain limitation for those fittings. So then we can get to filtration, right? So now we've got our fuel going in at the right time without the wrong tanker now screwing up our gas tank. We have a fuel pump either in tank or external, which is, depending on which way you position it, could be running hotter or cooler for the pump itself. And then we're going to want to put a nice tight micron filtration device for filtering between that and the injectors. A modern injector is rated for 7 micron for its little tiny injector hat from Inject Dynamics, which means you should be running tighter than 7 micron for all of your filtration. unless you want to be clogged and dealing with cleaning injectors all the time. So Injector Dynamics has their F750, which is, I believe, rated for 5 micron. It's a Bosch variant, something it's like 99.92% will still flow up until this point, and then it will finally hit its saturation point and
Do you
stop
have
the
any? Do you
restriction.
have like a maximum pressure that can handle? I've seen it a couple
It
of
is
times.
1,000 liters per minute. Is
But
that right?
okay, so that's volume, but not pressure.
Volume,
At
not
what rate?
pressure.
Yeah.
Yeah,
Well, we can
not off
look
the
it
top of
up.
my head. Yeah, we can look it
We can
up.
look it up. Anyway,
Continue. Go for it.
so moving on, you've got the pump in the tank. You've got your suck in the pump on the pump in the tank. Then obviously you need compatible hoses for the fuel you're going to run, and then from then on you need an appropriate post fuel pump filter based on the fuel you will run. So E85 and methanol. Keep in mind these things are corrosive to some materials, so you want to keep all the nasties out of the fuel lines and in the injectors, because eventually, as the injectors start to go, the injectors are actually, if you remember what we spoke about, mechanical components after the ECU that can't really be monitored. You're only going to be able to notice, hey, my pulse width is the same, but my AFRs are not. They're leaner. Well, time to look at what the injectors are doing. So periodically, if you run exotic fuels, keep tabs on your injectors, check them often. Some injectors, unfortunately, will reach a point where they just won't clean up anymore, and then you'll have to just replace them. After your fuel lines and filtering and everything reaches your rails, then it's time to consider what injectors you're going to run. Now, there's two camps: regular gas or even race gas and unleaded fuels, or the alcohols and methanols and that sort of thing. Your injectors need to be on par with the fuel you're using. The common recommendation is always go for stainless steel gut injectors, which will be more prone to resisting the corrosion effects of ethanol and E85.
On that note, so
Yeah.
not all injectors are made equal.
Created equal. Yes.
So just like an injector should be treated as aftermarket coilover damper. Okay, we're talking the shock valving, the way that a injector is designed is very much in the same train of thought as a suspension system. Okay, so even though they may have some of the same base components, how those, I guess, internal injector drivers are designed and the internal components and the shaping of those pintle and seat and the components for the small internals of that injector are usually changed from brand to brand to brand. Some are not. Some are simply just flow matched to each other and saying, this match matches this, close enough, send it out. And companies like Inject Dynamics will go through and actually recreate their own injector based on their needs using stainless internals for all their X series stuff. Those things will last with E85 held in the motor for a long duration, much longer than it probably ever should be. And one of the notes I wanted to make here was if you do run alcohol fuels, you cannot let this sit in your engine, in your fuel system by itself without having an additive to stabilize it.
Or best case scenario, drain the
gas.
entire system and just keep the car on pump gas as it sits stored in a shed, in a garage, under moisture, different temperatures, and every other condition that makes the fuel volatile and screw everything
Right.
up.
So I guess one of my suggestions will be to, instead of having a pure alcohol-based vehicle, run flex fuel. And so if you go to run the car every week, you can have E85. If you go to store the car for the winter, you already have your pump gas ready to go. And it's already tuned for that accordingly. And the second you put in pump gas, it knows, okay, we're at this point on the ethanol sensor. We're going to now require this change in our fuel mapping, blah, blah, blah. It's all already calculated. So at any given time, you could go cross country, run pump gas all the way across. You get to a place that has ethanol. You say, yeah, I want a little bit more power. I might as well take it. and you dump in your E85, and any blend in between there will now be corrected for the ECU when tuned properly. And
That'll
the
be part of
benefit,
the advanced features module.
yeah. But that'll be another thing to maintain the fuel system to not let it degrade as quickly, because as we run these more exotic fuels, the degradation and the time that they will last goes down, right? Methanol, especially, the more exotic the fuel, the less duration you have on the lifespan of the components being used.
Right. Now, moving on to components, then obviously we're at the rails already, and injectors are going to be a big thing, a big part of the whole equation. And one of the most critical factors that we as tuners need to emphasize and to sort of demand will be the fact that we want good injector data. We want the injector supplier to properly give us enough information for us to be able to put into the ECU to allow the ECU to be able to run correctly. Now, combined with the injector data, you also want to be monitoring the main thing to focus on, which is the fuel pressure. So with fuel pressure, you will need a fuel pressure sensor, and then this eventually will give you the necessary information, or give the ECU the necessary information to be able to compensate for variations in fuel pressure, to compensate with a failing fuel pump or a failing fuel pressure regulator where the things are not going as they should be. I see you got a
Yeah,
nice little table there.
so right here, this is a Grams, which is like a Honda company skunk tube. Um, if you have a generic injector, these guys usually do an extremely good job of documenting all of these generic injectors. This I think is very well done. Um, I've had zero issues using this. This injector is really cool, by the way. If anyone has, let's say, um, a good example is actually the center iron for a rotary. This injector drops into the center ports, and the shot is actually going into it very well because that extended
I
tip.
assume with this one you don't need the diffuser in
Yes,
the hole.
for all modern injectors, it would take out the center iron diffuser just
Yeah.
because they
Yeah.
atomize so much better.
Yep.
These would be really good for if you have some location in the engine where it doesn't get a direct port flow nicely, and so air is not coming across. Here, I'll go back to us for a second. So air is not coming across the injector face very well. So if you have an extended tip injector that's putting into the stream of airflow, it will atomize better to its job before it gets to where it needs to go.
Yeah.
So that was the point of that one.
And of course, the Injector Dynamics website has all the information on their stuff, which is fantastic. And they tend to do it as an ECU on an ECU per ECU basis, which is fantastic.
Which is fantastic.
Haltech will require slightly different numbers than a Motec and a Link, and they do the job for you. So that's a wealth of knowledge right there as well.
And that's because each injector driver for each of these companies is different. It's kind of a weird thing to look at, but when you look at the actual basis of how these boards are created, they're grabbing from different manufacturers of what they need, and then the way that they're making the components is not identical. So
There's also a cost involved. Obviously, we're talking very small electronics components, but when you multiply them by a few thousand, obviously the money gets piled up quickly. So that's why different manufacturers will choose a certain component over another based on their build quality, obviously the durability of the component, and the capability of the component.
yeah, on that same thing, that's why you'll see different ECU manufacturers will have like a 6 to 22 volt range, or some will have like a 8 to 16 volt range. So it's just all down to the base components. And that's why we're talking about the injectors, to where the data will always be a little bit different from manufacturer to manufacturer, just like the ECU data for that injector will be a little bit different for each.
It sort of goes to the point where each individual has its own profile. Even if we're talking the same part number of injectors, they will never be identical. The the components at the, let's say, the microscopic level will behave and function different. The coils don't behave the same way. One will, have a slightly different dwell saturation point than another. Each component has its own tolerances, if you will. So you need to be mindful of that when you say try to compare apples to apples and say, well, brand X injector is the same as brand Y injector. They're the same flow rate. They will never be the same. They're not identical. Just like two engines, one after the other, out after a production line, will never be identical either. There will be minute, subtle differences that need to be accounted for.
On a tuning aspect of this is why we can't copy and paste tune stuff. It never should ever work that way. If you see a file that goes from the same car over and over and over again, run. That should never, that sort of tuner needs to be like a proper talk to.
We can surmise it as you can start from the
You can
previous
start, yeah,
but
but
eventually you'll have to tweak it around,
everything will have its
make it
own,
work for it.
yeah,
Even the location where the customer lives, it's going to determine some of the parameters and how they work and how they're set up. So
right.
all the different variables have to always be considered. So nothing is equal in every way.
Right.
So be mindful of that.
So we've covered injectors. Let's talk about fuel pressure dampening and fuel pressure regulators. So
Very good.
Weldon is a very good company that handles methanol, ethanol, race gas, pump gas, all that stuff. I think they handle diesel. Weldon's very high up there. They have a very large diaphragm diameter. So if you have huge injectors all on the same rail opening at the same time, that's the key thing. At the same time, that injector differential pressure inside that rail is going to be dropping out very quickly. There are two ways to resolve this. Radium has a really nice fuel pressure damper you can add at the end of a rail that acts like a second regulator. And then you have the regulator itself. Claudio, do you mind pulling up the old, I think it was AEM or like extremely long regulator, long body for methanol stuff? So some companies, when you have, obviously there's multiple ways to approach a large pressure drop or a large pressure differential, but some companies went with a longer stroke for the overall dampening of your fuel pressure regulation. And some companies went with larger overall area, which is like what Weldon did. When you have a very high fuel pressure, let's say methanol stuff or mechanically driven stuff, 120 psi, this very tall, I think it was Aeromotive, actually. You got it?
Ding.
Thanks, buddy. So the Aeromotive here, this works really well for a mechanical standpoint. I think we're off frame here, bud. Oh, no, we're not.
Oh,
No, you're good. This works very well for a mechanical setup where you've got these huge dumps of fuel pressure. And what's inside of this is a diaphragm that's a very long style diaphragm. And then by contrast, you can have, so see, we can see this is a very narrow position. By contrast, we can have a Weldon A2047, which if we just type that in real quick, you can grab that. Weldon A2047. That's a much larger body regulator. These are rated, like I said, for all sorts of fuels. This is better, in my opinion, for multiple injectors at the same time on a singular fuel rail. So that's something to where you have to play with injection timing, and you can either offset and run multiple stages to have them on the same rail, or if you run them all at the same duration, because the phasing of that injector, if they're all in the same time, because they're going down into the port at the same location and the same airspeed, they should have the same injector time, right? Injection time. And if we try to offset that to get rid of this big oscillation in fuel pulsation, then it will help us to not have such a crazy, I guess, dumping of fuel in that rail. And it runs the rail dry.
Yeah, there's the Weldon one. Sorry it took me so long.
Yeah, no, that's good. So this one is a much larger overall base area with a shorter total stroke height. And that's a -12 on each direction. That's actually huge.
Big boy.
It
Yeah,
looks
Weldon
a lot bigger than
for big stuff.
so
Yeah. Yes. So yeah,
no,
the fuel pulsation damper actually is a dramatic helps dramatically improve how stable the mixture and the pulse width ends up being in the tune. Um, a colleague of ours did a nice little video showing the before and after of what the oscillation kind of nimbles out to, and it's really impressive. I don't, you know, I don't let customers not do it. These days, Radium has that nice one that it's either the regulator plus the damper, or you can put the damper on the rail. Yeah, there it is.
so
A
this is
fantastic
the
little
fuel
unit.
pressure damper that these come in. I think it's -8,
I think it's 8. Yeah, their
and then
stuff
they've
is mostly
got
8.
3/8 MBT as well.
Yeah.
So they actually have like a full vacuum reference or not referenced and pressure rating, and then they're actually running FKM sealing materials. So these are good for every fuel imaginable. They're saying you don't need to run this nipple here if you're within these static limits, and then when to run the nipple is based on, other limits. They actually have a very good little write-up here.
Yeah.
But
Yeah,
again,
those are pretty good.
This extra range here, and Claudia was referring to Chris Ludwig and the video and the
Yeah.
RX-7 page. This is back 3 or 4 years ago now,
Yeah.
and we all contributed to that one. That was a good one.
Yeah, it's been a while, but it was
Been a while.
very informative. I mean,
Very informative.
I started recommending it ever since, and it's
Yep.
really nice to have.
And I do it per fuel rail, ideally, because you want your regulator to get, if you're running a parallel fuel system design instead of it in series, it's splitting beforehand. And then when it's coming back, both ends are ending up at the regulator. So the regulator can do both ends of that. But then the feed side, if you're able to do dampening on that, you're gaining it from both ends of the fuel rail, each fuel rail. And then it's really balanced. So instead of having a fuel trace that might be plus or minus 0.3 AFR, it ends up being like dead flat. And the injector pressure differential, dead flat. It's an incredible thing to see. And that's actually what helped with the car that you wired and the one that I tuned, Mike Watson, who made like 733 horsepower the other day. His injector fuel trace is like dead flat, the flattest I think I've ever seen.
And what size injectors is he running?
He is running, I think it's like 1700 and 2600 from ID. And so we're talking big boy injectors, but it's only 2 stages. So if he had 4 2600, that's when we'd have the issue of like big pulsation on the secondary rail. Oh yeah. Dumping. But what we were able to do is raise a base pressure enough and give him enough dampening through a proper size regulator. Bigger is always better. Sorry. That
you had to go there.
I had to go there. Someone has to do it. So bigger is always better. It worked extremely well. And we had a fuel tracing that was the cleanest I've ever seen. Like if I target exactly a fuel, I could run 30 runs back to back to back to back to back. And it never skipped a beat past like 0.1 AFR. Like it was just perfection. So I can rip out and move things around as needed.
That's always nice to see when a car just behaves and no matter what you throw at it.
That is a very, very far reach from what we're used to. Claudio and I can attest this is not a common thing. No, so having the good components for fuel make a world of difference.
Yep. Most of the applications you see on a day to day are like sub, or not sub, but 400 to 450 horsepower, which is a really nice rocket ship if you ask me. But it runs
Price,
good. Yeah, it runs good. It starts cold. It starts hot. You can just stick your head in the window and fire it up, and there's no need to sit there with your foot on the gas. Idle control is nice. Stop and go driving, cruising. Customers just enjoy the cars. And if you take the time to tune it and to set it up properly, that's where all the data logging comes in, the information that you get for the injectors, proper setups, proper protection strategies, all that stuff will help. So just to really quickly go over a couple of things. Effectively, our setup for the fuel is you have your number of injectors, and obviously depending on whether this is a rotary application or a piston application, um, you have your injector data that you need to feed in. You have to properly calibrate your dead times for the injector and the flow rate based on fuel pressure. Now, normally, in the past, you probably would see just one cell value in your table for the flow rate and then maybe a single row for values for the dead times. These days, obviously, since we have injector suppliers providing us with more information, don't be afraid to put those values in there. The more you have, the better it runs. And of course, when you have that matched to a fuel pressure sensor and the AFR and your damper in the fuel rail, which helps mechanically, all that stuff just makes the whole thing run smooth as butter.
very well said. Yeah, I think that just about wraps it up for fuel systems. Can you think of anything else as far as I've got one thing I was going to add.
Well, we can do a little bit of a second part, kind of going into the tables and doing some target AFRs based on the different fuels. We should probably talk about that.
So, fuel pressure and where to find it for a given setup is a very important thing. I'm going to pull up, there's a setup here.
I'm a fan of putting the fuel pressure sensor on the regulator.
So, give me just a moment. We're going to open up this document that I use all the time. It's an Excel spreadsheet. And I'm going to just grab it right here. Boom. All right, guys. Right here, Inject Dynamics was nice enough to go and say what the actual flow rate of a fuel pump will be. This is like the cream of the crop of all the injector data you ever need. This is available on their library for Inject Dynamics. This goes through, let's say we have a 45 psi base pressure right here for a Walboro, or this one, for a Walboro, this is a 450 liter per hour pump with actually, this is the 525. This is the 525 with the restrictor, with the check valve, excuse me. And as we raise our fuel pressure higher and higher to the right, okay, this is adding more pressure. This is 3 bar, this is 4 bar, this is 5 bar, so on and so forth. The flow rate of the fuel pump will drop. And as a contrast, we have the injector flow rate will go up. And it is your job to identify whether we have a fuel pump to injector balance that is optimized for the engine. Now, do you want to have 20% overhead on the fuel pump? Probably not. Do you want to have like an ample amount of injector because you're running out of injector? That's a little bit safer in my opinion. Where you land this balance is a very important thing. So let's say we have 4 of these ID 1300s, right? And we've got them at 60 psi base pressure. So 1600 times 4. So that's going to be right about here, right? And that gives us just enough pump overhead to where we're satisfied and safe, right? If we were to go raise that up a little bit more, we're now going to be, let's say we go 75. That's now 1770 times 4. And we're here. Now we've run out of fuel pump. We can't do that. So finding this balance and explaining why an injector likes more fuel pressure. Let's go back on that. So, Claudio, what do you run for fuel pressures commonly?
Okay, well, let's take our streetcar example of 4 to 450. Usually, I try to set our base pressure to 50 pounds. So base pressure, which starts at key on, engine off, or engine idling, no vacuum line on the regulator.
Or
And
you
that
can kick
lets
the
you.
pump on.
Well, yes, of course, but even so, that's why I said key on, engine off. You turn the pump on through your ECU, or you jump the relay, whatever you do, and then you set your base pressure to 50 pounds. Now, what that does is that it gives the ECU the knowledge or the awareness of where the fuel pressure is. It's going to look at the fuel pressure sensor. It's going to say, okay, so the pressure needs to be this. So now, if the fuel pressure drops, it can compensate on the injector size and flow so that it can maintain a proper pulse width as the conditions change.
So, what I'm finding is, especially in natural aspiration, when you have a higher fuel pressure, the atomization is better, the
But there
engine
is a limit.
response is better, yes. And then it will reach a saturation point in where things are going to heat up more and then become less consistent. So, where we are setting our fuel pressure in that range, you're going to have to identify, is this the best optimization of the vehicle? Have I gone too far? Should I go elsewhere? So for me, I'm finding somewhere around 58 psi is a good base. And then if I find that we have components getting warmer because we have a higher fuel pressure that's fighting them, then I back that off maybe to 50 psi. And again, if we have a running out of pump situation, but not injector, drop it down even further to 43 and a half at 3 bar. So we're going to continue to move this to either optimize engine response up to a point or optimize the flow balance of injector and pump for the given configuration. Now, when you guys plan all this ahead of time, look like what we're going to explain how to do with fuel pump sizing and stuff like that, or you reach out to one of us on a one-on-one basis, that's when we'll go over that. That's when we'll cover, this injector is going to work well with this fuel pump, which is going to work well in this fuel system. And even maybe this car has a fuel starvation issue and you should go check out a surge tank because that makes a huge difference for anyone who has a hard acceleration 90s car, 80s car, whatever, and the fuel tank just sloshes the fuel, loses everything. And again, our source goes to crap. If our source goes to crap, everything goes to crap. Same with audio, same with cars. So
Yeah. So basically, what sums it up is you have a X amount of volume that's being flowed by the injectors or that's required by the engine to make the power you want. You need a Y amount of flow from your fuel pumps to maintain the injector's performance and the engine in turn. So I guess we can continue in the next couple of minutes, or should we do?
we're out. So we'll catch you
Gonna
guys in the
go.
next
We're
one.
gonna go and come right back.
Yeah. No, we're gonna jump into starting the engine and what to expect next.
There
Catch you
you
guys in
go.
the next one.
Boom.